All right, in this video I'm going to go into a little bit more depth about exactly how we create this gradient here in the loop of Henle. So what happens? Essentially, we actively pump ions into the interstitial space here, okay? And by actively pumping ions into the interstitial space, water naturally wants to follow, okay, to make sure that our osmolarity is equal in all parts. But the kidneys are smart, and so on this side of the loop, water is actually, the loop is actually impermeable to water. Water cannot pass the ascending side of the loop. It can't get out. But on this side it can. So water ends up leaving, and as that flow goes down, it becomes more and more concentrated, right? Because the water has left, and so it's increasing in its concentration. This side is highly permeable to water, but not permeable to sodium and chloride. This side is permeable to sodium chloride, not permeable to water. So what ends up happening is down in this part, down here, we have highly concentrated both interstitial fluid and filtrate here, okay, inside the tubules. And up here we actually have a gradient, right? So down here it's highly concentrated, here it's much less concentrated. And all of that is driven by what's going on right here in this particular section, the thick ascending loop of Henle. So in the thick ascending loop of Henle, we have this special transporter. It's a co-transporter, and it moves, for every 2 chloride ions, you move 1 potassium and 1 sodium ion into the cell, okay? That creates a gradient, which then allows for movement of potassium out of the cell, and for chloride out of the cell. We also have our sodium potassium pump, which is promoting that as well. So what ends up happening is we're pumping stuff into this interstitial space. And by the movement of our chloride ions, massive amounts of chloride ions, we actually make a potential gradient here. So it's more positively charged inside the tube than it is in the interstitial space. What ends up happening then? Our cations want to move into the interstitial space to balance out that charge. And that is what creates this huge, that's the driving force behind this concentration gradient that we're creating. By moving all of these solutes out into the interstitial space becomes much more concentrated than the inside of the tube, which promotes that water movement, creating more concentrated filtrate here down in this part. And that ends up being really important, like I said, not so much for this section of the nephron, but much more important here. Because here, in the collecting tube duct, what ends up happening is water is going to want to leave, again, because we've created this gradient here with highly concentrated filtrate interstitial fluid here and less concentrated interstitial fluid here. So the water is going to move out of the collecting duct into this interstitial space, concentrating the urine. I hope that was helpful. And I'm going to do one more video on the distal convoluted tubule coming up. If you like this video, go ahead and give it a like and subscribe to my channel. Thank you very much. Bye.